Good evening, everyone. There have been enough questions. I decided to record a video. I believe it's question 13 on the homework for week 11 on game theory. And so let's take a look. Let's make up a problem here similar to that number 13. And what game theory is basically when you have two opponents, each with multiple possible strategies for one of the opponent to maximize their potential. Either minimize loss or maximize gain. Either one kind of turns out the same. But let's come up with a game here where it's going to be me against my buddy Sam. Each of us, this is a game, each of us is going to have a piece of paper. And on that piece of paper, I can either write the letter A or B. And Sam has the same option. Sam can either write A or B on Sam's piece of paper. Now, if both Sam and I write A on our papers, now we're looking at this from my point of view, I am going to lose $2 and Sam is going to gain $2. So it's going to be a -2 from my point of view. However, if I put down B and Sam puts down A, I'm going to gain $5. Next, if I put down A and Sam puts down B, I gain $1. And if both of us put down the letter B, I'm going to lose $3. Of course, Sam will gain the $3. So this is our characteristic matrix, our win-loss matrix, or however you want to put it, for this game theory problem. To solve this, I'm going to jump over to Microsoft Excel. And so let's do a little formatting here. So we've got myself and Sam. Sam's going to choose A and B. I'm going to choose A or B. And we're going to put that matrix in there that we just had. -2, 5, 1, and -3. So now what I'm going to put up here, notice I left this line blank. This is going to be my proportion. In other words, the proportion of the time that I should choose option A or option B in order to maximize my winning. And of course, this value here really should equal 1. And this is going to be the sum of those two proportions. This one plus that one. Now, there are ways to force that to equal 1. But what we're going to do is we're just going to let it be whatever value it is. And then we will work from there. Now, I'm going to recopy this whole thing here and paste it. Because there's a problem. If I try to run this right now, it's not going to work because there are negative values in the matrix. We want everything to be converted to a positive outcome. So what we're going to do is we're going to take the most negative value, which is that -3, and we're going to add enough to bring that up to either 0 or a positive number, which means I have to add at least 3. So I'm going to add 3 to every value here. So -2 plus 3 is 1, 5 plus 3 is 8, 1 plus 3 is 4. -3 plus 3 is 0. So now I have all non-negative values in that matrix. So then this value here is going to be my expected value if I have these proportions up here. I'm going to call this P1, P2, really X and Y if you want to look at them that way. Let's insert a line here so I can label those. So we'll call this X and Y, the two proportions. So this outcome here is going to just equal this value times this plus times this. That'll be that projected outcome. So then we're going to hit equals here. This value times X. Oops, I put in plus, not times. Let me back up there. Times X plus this value times Y. And now to come out with what proportion we need, we're going to fill these two cells is going to be our proportions. We're going to go to our solver. Now we could do what we're really trying to do is we're trying to maximize the function whose goes z equals x plus y. Under the constraints, that's 1x plus 8y is less than, we don't know what this value is though. Some value there that we don't know what it is. We have 4x plus 0y is less than, again, we don't know what that value is. Now, there are ways we go through, we'd actually divide by the value and come up with that and redefine x and y to be x divided by that value and whatever. To simplify it, we're just going to run this using the Excel solver rather than trying to solve this linear programming problem where we have those unknown v's. So we'll go to data analysis here. Oops, let's go to data, select my solver. And so the cell I'm trying to maximize here is this one right here. I'm going to maximize it by changing these two cells. That's my x values. My constraints, well, this value, I'm putting less than or equal to 1 is what I'm going to put in there. And this value, also less than or equal to 1. We don't know what the value is, but we know it's the same value. So we just put in that same number of 1 there. So we're done. So we'll get out of there. We'll set this to simplex method and go ahead and make sure that make unconstrained variables non-negative is checked. And we'll hit solve. Of course, we hit okay to allow it to refill the cells here. So here's what we have. Now notice this number here is not 1. Those two proportions should add up to 1. So what the true proportions are going to be, it's going to be this value divided by that. And it'll be this, it'll equal this value divided by that. Now you might not recognize those, but this is actually, what is it, 8/11. Oops, well, let me write it as a fraction of it. And this is 3/11. Those do add up to 1. So what this is saying is 8/11 of the time, or 0.7272 proportion of the time, I should choose option A. And 3/11 of the time, or 0.2727, I should choose option B to maximize my output here. Now in our problem, your numbers might be a little bit different, but the numbers I had, let me get to a different cell here. So we're looking at, what were the names here? Runman. Oops. Runman was the one company. Mergent Center across there. And then over here, we're going to do INOD. And I'm actually go down one. And I'm going to either go to New York or Boston. And the representative from INOD is either going to go to New York or Boston. Notice I'm leaving this blank up here. That's going to be my proportion of the time again. So X and Y. So this is going to be, those two have to add up. So if we both go to New York, for the problem I had, your problem might be slightly different, but I lost $800. If I go to Boston and I go to New York, I gain $1,700. If I go to New York and the INOD rep goes to Boston, I gain $700. And if we both end up in Boston, I lose $550. So here is my gain win-loss matrix from my perspective. So then this is going to just equal this value divided by that plus this value divided by that. So this one divided by 0. What's the C2D2? Okay, there's no values in it, that's why. So equals this, not divided, it should be times. I go back and change that. Plus this times that. So I go back, this should have been times, not divide. So equals this value times the proportion of the time that it'll happen, plus this value times the proportion of the time it'll happen here. Now, again, if we run this right now, there are negative values in here. It's not going to work out well. Now, I'm going to copy and paste this over here just for a second. If I try to run this with the solver, so I'm maximizing that value by changing those two, subject to this being less than or equal to 1, and this being less than or equal to 1. Linear simplex method. It gives us some weird things. 3/5 and 2/5 is what that actually comes if we divide that out. But that's not correct. The negative values here throw us off. So what we're going to do is we're going to add 800 to each of these values. So 800 plus 800 is 0. 2,500. 700 plus 800 is 1,500. And negative 550 plus 800 is positive 250. So now let's run this solver on this matrix. So we're going to maximize this value by changing those cells. Get rid of these constraints here. Add this is less than or equal to 1. And this is less than or equal to 1. And let's run it. And this time we will correctly get the values in there. Now, we do still have to divide these out. So this equals this divided by the total. And this equals this divided by the total. Okay, we do end up getting the same values in this case of 0.6 and 0.4, 3/5 and 2/5. That is the percentage of the time that we should be at each location, given those values. Now it's, did I have a number off? Nope. All right. So that is how the game theory works. A little counterintuitive, but it's pretty simple, especially if you use the solver function in Excel. It gets really messy if you try to actually do it with a graph, because like I said, you don't know what these values actually are. So you end up having to do a division in order to make those values work out. If you have any questions, please let me know. Hopefully that helps you out with that problem 13 on homework 11.